Well, we're starting early here, so please don't go yet. We may get some drifters in from the other room. So yeah, thanks for having me. We've had some really good talks today. This one's going to be a little bit different. It's not going to be exceptionally technical. It's going to address a few things that have been on my mind, some observations for quite some time. And my thinking here is that our technology and our hardware, Moore's Law, everything has really improved. One thing that we're a little bit behind on, I think, is actually stepping back and thinking about the quality of the data that's coming through our systems that we've been working on. So I'm going to kick things off with my version of a play. So this is me talking to a bot in AI. Maybe it's my boss in a few years. So I'm asking it some questions. It's giving me some answers, which is great. I'm sure lots of us are, or hopefully lots of us are already doing this type of thing. And then finally I ask it how confident it is about those numbers, because that's not something that we always ask. We just assume that, oh, this is right. Okay, move on. So I think we're in this period right now where we're not always sure, actually, about how confident some of the statements we are making are. Up until this morning, I actually still can't believe my fellow countryman, Justin Bieber, is in the top 5. So that's a personal motivation. It's something I might actually have to take up with Shazam and look at a bit further. Why am I talking about this today? Like any big data event, we should take an analytical approach, right? So this is a breakdown of all the talks that are on today between this room and the room beside us. I'm the only person talking about data quality. Everybody else is talking about the technology, the business applications, and how we're processing this data. So that's why I said this is going to be a bit different. Who knows what's happening in 2020? Yes? What's happening in 2020? All kinds of things. Of course, all kinds of things happening in 2020. The context here is that this is the date that 5G is supposed to hit us, where everything, so the stage, the carpet, the walls, whatever, are now emitting data, right? This is the enabler, apparently we're all waiting for, to truly adopt the Internet of Things. So I think that we have a little bit of time to go, but once we hit this and everything is sending this much data, then we truly will be in a world that is actually emitting, capturing, and processing a lot of data. Here's a personal motivation. So this is last April. I was with my family on a holiday, and like most families with young children, you're arriving pretty late to the airport, and you can't actually see what airline this is. So I'm not going to name and shame them. I couldn't check in. I tried checking in online, no good. I tried checking in at one of the kiosk terminal things, no good. Now by this point, we need to board this plane in a few minutes. Why couldn't I do this? Well, because it thinks my title is appended to my first name. Yeah, I think we all get that, right? We can look at that, but these machines could not. Now, somewhere along the chain of information exchange, this happened, and it prevented me from getting on this flight. So this was a big personal wake-up point, saying, okay, hold on, yes, we're capturing lots of data, it's going through all the right places, but something is happening to it. It mutated. That shouldn't be happening. We should have a blockchain for this. This is another graphic. I'm sure some of you have had it, but look at that figure. $314 billion is the cost of bad data in healthcare, allegedly. Now that's a lot of cash. It's being wasted. If poor quality data is behind that, like we as an industry, as professionals, practitioners, whatever we are today, we really need to do something about this. The final one, some of you may remember a news story that emerged a few months ago. This is where an autonomous vehicle just decided to, I'm sure informed on with good data, maybe not, decided to merge at about 2 or 3 miles per hour into a lane where a bus was oncoming. And sure enough, the bus hit it, right? So there's something we need to learn from these situations to improve upon this. And what's going on? This image, I grabbed this yesterday. Does anyone know what this is? This is the second series of autonomous Uber vehicles on the street in Pittsburgh. So these just started, I think on Tuesday, somebody spotted one. But what's going on in that car? Somebody is sitting in the driver's position, right? And why is that? Well, there's a trust thing going on. Why is there a trust thing going on? There's a quality thing going on. And what's behind all of this? Well, we are, right? Because we're making machines. And we're making that. Could we go back to the presentation, please? We're making machines. We're making the software inside these machines. We're making the sensors, right? So it's us still. It's not a robot. It's not artificial intelligence. Yes, those things are improving and hopefully are going to improve this. But we have a big corporate responsibility, government responsibility to do something. I'm going to breeze over this one in the interest of time, but I'll point you to, there's a really good github.com article here that is actually outlining a lot of the data problems that we're seeing, that we're talking about. And it's very, very useful. This may seem really obvious to most of you, and it is, but ask yourself, well, when did I actually last go back and think about all these things? When did I look at the data that I'm relying on in my organization to make my decisions, or my autonomous Internet of Things do all this magic stuff for me? So I'm going to break things down into what I'm going to call 2 main pillars of data quality. So one of these is data integrity, and when I say that, I mean how complete is this data? So is it here? What's inside it? Is it intact? What's required? Are these details actually being submitted? How do I interpret it? What does it mean? If I walk off the street and then look at this piece of information, do I actually understand what it is? If I'm a machine, is there a contract? Do I know what it is? How does the data change? If I'm not emitting this anymore, I've changed the name of it, or I've decided not to emit it, then how does that affect the downstream consumers of that? Who's still reading it? And then there's the validity. So one is sort of the integrity of the structure. Then there's the validity. Are the values making sense? Are they expected? There's a graphic here. Anyone who works in travel may recognize this conundrum, but basically what's happening here is that 2 of these airports are in New York State, and one of these isn't. And what travel data models like to do is group them together. I'm flying to New York. I don't care what state it's in, but of course machine systems and processing and analytics do. So we have to make a choice. We need a rule engine in there to decide where it is. These things differ greatly between suppliers of travel information. The one that isn't so much of a pillar is data presence. And this is the loose pillar that I describe as the notion that if the messages are actually being emitted, and what is the volume and frequency of these like? How do I know how many should be? If this is a Boeing 747 engine, is it normal to get 14,000 terabytes a minute or whatever those figures are? Or is 12,000 okay? I don't know. What does that mean? So when we approach integrity, what we need is what I would call a data definition. And I'm going to use the term event schema, but I'm not going to use schema in terms of the relational database term, which based on my experience, I think a lot of people mix those two things up. So when I refer to schema here, I'm referring to the notation of a message and the structure and integrity behind that. Tech examples of these are protocol buffers or Thrift or Avro. You've probably heard of these. You should check them out. They're very useful. They'll become even more useful. I describe this as the great trade-off. So because we have all these great ingestion pipelines now, somewhere we need to be thinking about where do we work with data integrity. Do we do it at the time the data is written, or do we do it at the time that it's being read, or do we do it somewhere in between? It doesn't really matter. There's a cost associated with every position along here, but we should be thinking about it and optimizing where it means the most for our system in our business. The most important takeaway here is that we understand this and have to do something about it. Here's the second act of the play. So now I want to start measuring how effective our decision making actually is, which means I need a measure of the quality. Again, the bot engine, the artificial agent here doesn't understand this. It says, am I from the future? Is this crazy? No, I'm thinking about the future. So what are we doing to address this at Skyscanner? We come up across data quality issues quite a bit. So I'm going to just very quickly show our version of the data platform, which we've been continuing to build and exploit over the last couple of years. Basically, on the left side, we have the ingestion area. On the right side, we have the consumption area. And then in the middle, we have this unification point, which is in big letters, Kafka there. That's Apache Kafka cluster. And we are utilizing those points. So I'm going to focus on that middle area in the hopes that when we get through to the consumption side, we don't have as much to think about because we already have this in place. It's running very effectively. It's very useful. And the point is that there's actually very little left to do now because we're using some schemas. We've got a notion of our integrity. We have a notion of what quality we should have. And we've got all the right tech. Here's the data definition. So this actually is a snippet from a protocol buffer data description. And what you're seeing in there will look hopefully very familiar to most of you as some sort of structure and schema of saying, okay, what kind of value is this and what should be expected in there. The last bit at the bottom here is actually just a simple strategy here that if the data cannot match that schema footprint, then we should do something with it. So what do we do with it? We put it on to, if you follow the red line in this diagram, we put it onto its own topic. I'm going to sort of glaze over the idea of topics and event streams, just hoping that most of us are familiar with that. So now we have a dead letter queue type system where all of our bad data, or the data that doesn't fit, is now on its own topic and can be treated like any other type of message. But what it is a measure of things that aren't right. Now, for data validation, this will look hopefully very familiar to a few slides ago, where we described a trade-off for integrity. Similarly, between data in and data out, we also have an opportunity here to validate the data for its quality, not its structure, not its integrity, but what we might expect to be in there. This time around, the cost is about the same. There's no difference. It needs to be done. So again, takeaway is do it somewhere. We've chosen to do it as near to the right area as possible so that other processes downstream can benefit from that. Now, here's a fictitious example of some configuration that can be used to assess an individual data point. So this is what, if you remember what I was talking about values and validation, these might be what you would describe as a constraint on a table creation or something. It's a very similar thing. They're expected values between x and y, or it has to be a number, or it needs to be a string of this length. So when you have that, going back to a similar data flow, you now also have an opportunity to catch those messages, the ones that are subject to data validation issues, and then retopic them. So again, another dead letter queue that we can then fit through this whole pipeline and process and feed back to either the data producers or the data consumers, which often are the same people, right? So now we're starting to build a feedback loop, right? Where the consumer of the data and the producer of the data are both interested in this. And that's actually really significant when you have a pipeline like this. A lot of people complain like, hey, those guys are producing really bad data. What are we going to do about it? Oh, I don't know. Well, in this case, we do know, because they're directly impacted by the quality of their own data. So here's an example of like what this actually looks like in principle and not just fictitiously. So we get some big massive stack trace from some kind of stream processing job, and we get a big spike in a graph somewhere, and then we send out some alerts and somebody reacts. Now, this is not uptime. This is data quality. This is like, hey, something's not right in our system. We'd better do something about it. So I mentioned this idea of the loop and the feedback loop. So all we have to do here is close that loop. So we've got our data producers, we've got our data consumers. We have this notion of a shared place. So this could be a Git repository where we all have access to the same rule system. We all have access to the same data integrity system. So all we have to do is actually all commit to that and then use it. And it's another formation of a contract between data producers and data consumers. And if we can't measure it, then how are we ever going to improve on it? So going back to the beginning, I think we have a responsibility to do this. And if we don't measure it, then how are we ever going to know how we are doing about this? So I think there is a simple equation here where we measure the issues we've been detecting, so these dead letter queues, and then we somehow get a notion of how we're fixing those things. So are we adding new catches or validations for this data? And then just divide that by the number of events that are making it through, that aren't in our dead letter process. And over time, I believe that we're going to end up with a percentage of data quality assessment. Now, there's an example figure. That doesn't mean that's what the world is. I doubt very much it is anywhere. So in my closing statements here, I'll make a few tips for how we can also improve data quality along with that feedback loop. We've heard a lot today about one source of truth. The blockchain helps us do this. I think the same thing in our own systems, maybe before we've adopted blockchain or figured out how we're going to do that. Let's just make sure that we use an authoritative data store that all of our systems and our architecture are using. If there are international standard sets, use them. find them, and embed those into your systems. And then when we're processing data with this single source of truth, bring it as close and as close upstream as you can to the data processing, so that it's consistent. Data provenance, traceability, hot topic, metadata. Where's my data? Do you have my data? Where has it been? I want to know the history of it. I'm now in control of my data, or hopefully am, my personal data. So I want to know all these things. So we need these techniques to properly trace our data. We've come up with this idea of touch pointing messages along their chain. So every time, we don't mutate data. So every time a message comes in, we stamp it with where it was and how it relates to the last thing that has happened, right? So this is the same AB to B, C to CD kind of pattern that we're seeing emerge with from blockchain as well. Data change, again, really another hot topic, because at the end of this all, we're going to end up with data tables or lakes or warehouses or reports, and we somehow have to keep up with the fact that the flexibility that we've traded off here for more structure downstream, we're going to have to cope with that. So we always have to maintain backwards compatibility. So if we start changing fields, so here we're in a motion of changing the screen dimension size as an example, and then we're deprecating it and we're commenting it out in its life cycle. Now a lot of people will say, oh, this is scary. How do we cope with that? I've got this big data warehouse table. Thankfully, with the way that processing and technology have improved, it's actually pretty simple now. All we have to do is rebuild that with it in mind that things change between those 3 periods. So all we have to do is build that strategy in and then recreate the whole thing rather than try and patch it up in some crazy way. And in terms of culture, this is a graphic I saw somewhere in Edinburgh, and obviously someone was complaining about the system, but somebody even more clever came around and said, oh, actually no, I'm going to not complain about the system. I'm going to do something about it, right? And it got me thinking, because going back to data quality, yeah, we've got some data quality issues out there. Not many people are talking about them, but it's pretty clear that we need to do something. So let's, stop moaning about it and actually be proactive and do something about it. So this is your opportunity to walk away from here today and start doing something about it. Just step back and think about your data, the data issues. You'll be hearing about them, I'm almost certain. Try and unify and simplify things. Use the single source of truth. Whatever you have, like if it's an old system or a new tech system, like use it, exploit it. Have a think about like what you have there and what easy opportunities you might have. Start measuring. Like if you're not already measuring all your stuff in your systems, instrument it, look at the data, and improve it from there. It's not too late. I don't know if 2020 is a hard date. It certainly is hopefully the date where Justin Bieber isn't in the top 5, but we'll see about that. Final act. So this time we've gone through this world, we've improved everything. So this intelligent agent now is actually really intelligent. It's telling me, it's giving me numbers about how good the decision is. It's even making me recommendations or ideas about how intelligent it is getting. Maybe it's machine learning. So now it's like, hey, I think you can improve these, your sales figures. I can uplift it by another percent or a few percentage points simply by just improving your data quality and not doing anything new in your business. That's it. So go forth and improve the quality of your data, please. Thanks. So we've got some time for questions, I think.
I enjoyed your Slack bot a lot. Does it actually exist, or is it a plot device? And if it does exist, where can I get it?
Okay, so this one here in the presentation, it doesn't exist, but there are lots of examples of Slack bots that you can integrate into your metrics source. Actually, I think Amazon just recently did a very good bot challenge, out of which came some pretty interesting Slack bots. We've done some interesting work where we can analyze some of our infrastructure, like that pipeline diagram that I showed up. We can query a bot as if it were a human. It can tell us stuff about the health of that cluster, for example, maybe how much it's costing in cloud hosting, stuff like that. It takes a person out, it really does, and we're seeing evidence of that. It's something we open source, so you can continuously commit to it. Internally open sourcing that bot. But again, open source, there's lots of great bot examples, and they're really fun to make. Any more questions, comments, travel questions? Everybody a Skyscanner user here, hopefully? Yeah.
Hi, thank you for the presentation. I think it's really important to talk about data quality, and I do appreciate those set of steps, but from my experience, the biggest problems with data quality have come out about stuff that no one has really thought about. So the stuff that you're doing is sort of like, if I can sort of predict what the problems are going to be, then I can sort of quantify it. But a lot of these are sort of like, in Donald Rumsfeld's terms, I guess, the unknown unknowns. Mm-hmm. Do you have any advice on that?
Yeah, I think about this quite a bit. So we saw the black swan, unknown, and we saw machine learning as a way of trying to predict what data quality problems could be coming. I'm not quite sure what we should do about that, but one that I think about a lot are weather instruments. And as we get more IoT weather instruments, so for example, I have a temperature gauge and a wind gauge in my backyard. And in the winter, these things start to give off really weird results because maybe it's iced over, like a few leaves have fallen on the thing. And if I look at my data distribution versus people around me in my area who also have these things, then like we have to start scoring that. Or maybe I should be alerted, or maybe I should get a predictive alert saying it's autumn, the leaves are going to start falling. I don't know why I need to be alerted about that, but it's one example. Another one might be there's very cold weather coming. Watch out for ice buildup. Stop sending to the World Weather Network or whatever. But yeah, I think there's a huge opportunity actually about trying to predict what data values aren't going to be quite right. In terms of the ability to do something, that was my point about us, humans, still being the ones that actually have the responsibility for doing this. So it's our applications ensuring that they're robust enough to handle the exchange of data. I don't know how my title got appended to my first name. It certainly didn't start that way, but it happened, right? So we should be defending for that upstream, especially when we're exchanging information between all these various systems in between.
Hello, thank you for the presentation. You mentioned data validation a lot, and I just wonder how much of a problem was it for you? Because when you think about Skyscanner business, then the data seems to be formalized pretty well. It's just the flight and the fields are clearly defined, and you can, when you integrate providers or the information, you probably solve this problem right here, the step of the integration. So obviously, it must be a problem since you mentioned it. So can you please elaborate a little why was it a problem, and how did you what was your approach to it?
Yeah, thanks. That's a great question. And you're absolutely right. We have integrations with over 1,000 travel partners, all who have their own data models and their own formats. So we have to go through an incredible normalization process for that data. So that's really the first step. And then the second step there is also by applying one of these meta data management style solutions where, okay, I'm going to check these values coming in because, if Newark, is Newark in New Jersey or is Newark in New York State? Oh, this provider's saying it is. Which one are we going to use? We have to make a decision. So, we can either change the world's geography or we can make a specific one. So we'll do that type of decision making as well. And then we will have to, at some point, make a call on whether that data is actually quality enough to be put in front of a user or a customer, because the implications of it are actually quite serious for a traveler, because you might go to the wrong airport, for example, or you might book the wrong ticket, that kind of thing. So we will reject data if we just can't figure out if it's valid enough. So it's customer first. We will try and get that information back to the supplier and say, hey, look, you said Paris is in Papua New Guinea. Not a real example, but it would be the thing. And so we have that feedback loop and process as well. But that's evolved over a lot of time. And again, we can't always predict what's going to happen, to the other gentleman's point. So. Okay, great. Let's wrap up there. Lunchtime. Thank you.